Hello, friends, and welcome to a lecture on operation research. In operation research, today we'll be taking up a problem on dynamic programming. And in dynamic programming, we'll take up the problem of employment smoothing. Now, this is a very popular problem which has been asked in most of the competitive exams in India, and there are lots of videos in YouTube on it. I'm not the only one to produce it, but yes, uh, stick along because here, why a solution, what the how, rather than showing the hows of the solution, the whys of the solution are saying why we take a specific method to solve it. Now each dynamic problem has a different approach. Now most of the people do not discuss about what is the reason to take the approach to solve the employment smoothing problem. They just put the solution. Here we'll be discussing a bit into why we take the solution strategy. And mind you, the solution strategy, after it is understood, becomes very simple because a similar kind of problems, then you need not go and, try solving them. The reason is once you know an algorithm, you know almost all the algorithms of solving these kind of problems. Well, this is Professor Arvind Prasad, and do like and subscribe my channel. So let's get ahead. So before we start solving the problem, let's look into how we solve a road system cost of stagecoach insurance problem. Now, this is a very common problem that is used in dynamic programming to demonstrate how a dynamic programming is done. So, what do we have is in the good old days, you had fortune seekers who would go from city to city in search of gold in the wild, wild west. Well, I will explain this problem in a brief, but look at the link at the top and the bottom of the video where the clarification of this video is given, or where the commentary of the video is given. There you will find the link to how to solve this problem. And if you have already seen that, it would be a good idea that you can skip and and go ahead and look at the solution of this problem itself. But if you have little idea of how do we solve dynamic programming problems, it's a good idea to take a brief recap. But if you want to understand in detail how this problem was solved, please go to the link and watch it. Of course, the advice is always watch that problem and come back because that is the basic template of solving it. So let's get ahead with explaining this. So the fortune seeker has to go from city to city in search of gold. Well, if he strikes gold in any city, he stays there, he makes money. But then it was wild, wild west, and you had a lot of risks traveling from cities to cities. And the stagecoach companies, that is, the coach companies which took you around from one city to other city, they offered an insurance. So if the route was safe to any city, the insurance premium was less, and if it was high or if it was dangerous, the insurance premium was high. Now, in this problem, the fortune seeker has to go from A to J, but he cannot directly go there. He has to first go from A to either B, C, or D. Then from there on, he has to go to E, F, or G. Then from any one of these cities, he has to go to H or I. Then from H or I, he has to go to J. So, what is the best path that can be taken in between these cities so that the insurance premium is the least? Now, how do we solve this? First is we divide this entire network into stages. To start with, A is stage 1, B, C, D is stage 2, E, F, G is stage 3, H and I is stage 4, and J is, of course, stage 5. It's the last stage. Now, from any stage, you have to travel to the next stage. That is, from A, you have to travel, that is stage 1, you have to travel to stage 2. In stage 2, you can either travel to B, C, or D. So, in any stage, you have states. The states are the cities. Like in stage 1, in stage 2, you have city B, C, or D, which is state B, C, or D. So the decision on any stage is which stage would you go to the next, and in the next state, which state do you go to, right? So from A to C, C to E. So stage 1 to stage 2, you go A to C, that is from state A to state C. And from state C to state E, that would be stage 2 to stage 3. Now, the question here is which life insurance policy to choose each time when you go from one stage to another stage. Now, that is known as a policy decision because you have costs that are involved if you choose to go from A to B or A to C or A to D. So, as we just said, each stage has a state and policy decision decides the change in state. Now, what are the steps to the solution? The steps to the solution obviously is you have an optimal policy to travel in between stages. That is, whenever you go from one stage to another stage, you evaluate your options and you have a policy on which is the next state you're going to take. Or when you have to travel from stage 1 to stage 2, you have a policy which will decide from a state in stage 1 which state will you go in stage 2. And then of course there's a function. You write a function for this because it's a mathematical problem, so you have a function to evaluate this and you evaluate the function over all the states and therefore it's the objective function. Your idea is that this objective function needs to be either minimized or maximized depending on what you want. So this is what we have. To recap, you go from A to B. So when you go from A to B, it's a change in state. You go from stage 1 to stage 2. But from stage 1 to stage 2, whenever you go, it's a change in state. And then, of course, the line which you have in between A and B, it is known as the stagecoach run. So the function or the objective function is going to have the inputs, the stage at which you are in the state at which you are in any stage, that is, and the other input is which stagecoach run you are going to take to go from there to the next stage. Okay, I repeat, the function or the objective function is going to be having two inputs, is going to have two inputs. One input is the state at which you are there in any particular stage. And the second input is going to be the immediate stagecoach run that you are going to take to go to the next stage. So, what is the objective function we can write here? So, the objective function obviously we can write here is the immediate cost going from A to B plus the minimum future cost in going from stage 1 to stage 5. Sorry, stage 2 to stage 5. If you have to go, you start with A. The objective function is going to be nothing but the sum of the immediate cost which is required in going from A to B. Then that plus the minimum future cost or the minimum cost required in going from stage 2 to the 5th stage. I know it will raise a doubt in your mind that we don't know it. Because we do not know what is going to be the minimum cost in going from stage 2 to stage 5. But then the solution is all about that. So let's take up this problem now. And let's see the similarities in between this problem, that is the employment smoothing problem, and the stagecoach problem, and let's solve it. Okay, so what you have is a company needs to allocate salesmen to 3 zones. Now, as you can see here, if you allocate 0 salesmen to either of the zones, that is zone 1, it's going to be 30, zone 2, it's going to be 35, and zone 3 is going to be 42. These numbers are the profit that you can get or the sales value that you can get out of these zones. So as you can see, if no salesmen are appointed in any of the zones, you get a very minimal sales value from these zones. But as you keep increasing the number of salesmen, the sales go up or the sales value go up. But the progression of number is different in zone 1. The progression of these numbers is different in zone 2 and is different in zone 3. To start with, the company has only 9 salesmen. Now, how do you allocate these 9 salesmen optimally in zone 1, zone 2 and zone 3 so that you get the maximum sales? Well, that's an interesting problem now, because you have to search the best numbers or the best allocation amongst a huge array of numbers. It's like finding a needle in a haystack. So how do we go about solving it? The first thing that we do is we take any zone as a stage. And within a stage, the state is the number of salesmen allocated. The state is the number of salesmen allocated to that stage. Now let's say we start with stage number 1, which is zone 1. We allocate, let's say, 5 salesmen there. So 5, 9 minus 5 makes it 4. So 4 is going to be the state in stage 2. Now, what's the decision variable or the policy decision that you're going to take? The policy decision you are going to take is allocating the number of salesmen in zone 2. That is, you cannot obviously take all the salesmen that has been come as a leftover after allocation to zone 1. You have to allocate the best numbers to yourself, and then of course you have to allocate to zone 3 also, so that all the zones are represented by the salesmen and you make the maximum profit out of it. Now, one interesting thing before we get ahead to solving it, you have to see that as the allocation of salesmen goes up, the profit goes up. But then at the end, it also tends to taper off. And in case of zone 1, it also goes slightly down. So how do we solve this problem? We draw a table like this. You can see the table here. Now this table is for zone 2. So this table is for zone 2. Now this table, what we do is we draw this table, and in this we have 10 columns and similarly 9 rows. And in this row, okay, in this first column, we write the amount of salesmen that we have got from zone 1. Now it can be right from 0, it could be 9. Now here we have on this columns, that is the first row, the column headings are nothing but the number of sales team allocated in zone 2. Well, I repeat myself once again. In the first column, we have the number of salesmen allocated to zone 2. It could be from 0 to 9. Now, why it could be from 0 to 9? You may have a situation where none of the salesmen were allocated to zone 1 and all of them came to you. So you have 9 allocated. Or you would have a situation where all the 9 were allocated to zone 1 and you received 0. You have to analyze all scenarios. So we start with scenario where 0 salesman has been allocated to zone 2, right? And therefore we can allocate to zone 2 only 0 salesmen. So what is going to be the sales value that we are going to get? It's going to be the immediate cost plus the future cost. Now the immediate cost is of course going to be 35 and the future cost is going to be 42. Why? Because if we allocate ourselves 0 salesmen, the sales potential is going to be, or the sales figures are going to be 35, and from zone 3 it is going to be 42, because it shows in the table that if you allocate 0 salesmen in zone 2 or zone 3, you are going to get 35 and 42 as the sales numbers. So there we are. The addition of that is 77. Now let's get ahead. What if we allocate one salesman to zone 2? That is, we have allocated 8 salesmen to zone number 1 and 1 salesman comes to zone 2. Now we have two options here. One option is we allocate 0 salesmen in zone 2. That's it, 0 salesmen. So what is going to be the sales we are going to get? The total sales that we are going to get is zone 3 is going to be allocated 1 team. So it's going to be 54 plus zone 2, 0 team. So that's going to be 35. So 54 plus 35 makes it 89. Now the second scenario is you can allocate 1 sales team to zone number 2 and 0 sales team to zone number 3. So the total sales that you're going to get is 45 plus 52. That makes it 87. Now, similarly, what we do is we create a table like this where I had shown you how do we solve it for number of salesmen in zone 2 as 1. Similarly, if you have number of salesmen in zone 2 as 2, the allocations that you can make in zone 2 is either 0, 1 or 2. And the addition of numbers, that is the sales number you are going to get is 85, 99 and 94. Similarly, it's for 3. Similarly, it's for 4, 5. The entire calculation is done. Right? Now, from each of these rows, we note down the maximum value. So, from 89 and 87, we write down 89 here. From 85, 99 and 94, we get 99 here. From 105, 105, 106, 106, we get 106 here. Well, if the numbers are repeated, what we do is we just note down the number. Now, let's proceed to zone number 1. So, what you have seen is we have started with the pre-penultimate stage. Well, that's the trick always. You start with the last but one stage. You start the calculations and you keep moving back with calculating the previous zones. Now, in this case, we started off with zone 2. Now we come to zone number 1. Now, in zone number 1, well, all the salesmen are available to zone number 1. So, from 9, we can allocate 0. If we allocate 0, then the sales is going to be 30. And if 9 are allocated to zone 2, the highest sales that we can get is 167. Well, how will that happen? We'll have to take the highest number from these rows, which is 167. So 167 plus 30 makes it 197. So what is it going to be? If we decide to go with this number, it's going to be that you allocate 0 team to zone 1. And then afterwards, 167 is the highest number. So you allocate 4 teams to zone 2 and 9 minus 4, you allocate 5 teams to zone number 3. That is the meaning of these numbers. Now from 9 teams, if we allocate 1 team to zone number 1, the figure is going to be 203. 2 teams, 207. 3 teams, 210. 4 teams, 209. So on and so forth till 9. Right. Now the highest number here is 210. So it means in zone number 1, you have to allocate 3 teams. Now 3 minus 9 makes it 6. So we come to 6 in zone number 2 table. And we look at where is the highest number. It is 140. So it's 1. So in zone 2, we allocate 1 team and 3 plus 1, that makes it 4. So 9 minus 4, that is 5. 5 teams we allocate to zone number 3. And the total profit in this case by this such an allocation is going to be 210. So as you can see here, it's a combination. It was not a very direct answer. One couldn't merely look at the table and guess these numbers. So we have gone in a very systematic way of solving it. So, of course, there we have the solution now. Demonstrated 3 teams to zone number 1, 1 team to zone number 2, and 5 teams to zone number 3. So that's the end of this. Hope you have enjoyed this lecture. If you have any doubts, do write in the comments. And if you have liked this lecture, do like and subscribe my channel and share the link of this video to others who might be interested. Goodbye, friends. Have a great day. Have a great time.